Hi, welcome back to our Algebra 1 video playlist. On this video, we're going to look at how to graph our absolute value functions. So an absolute value, if you remember, is the distance away from 0. So absolute value, that is the distance that a number is from 0. Which means that I can't have any negative numbers. So when I go to graph my parent function, the original absolute value function, what that looks like is if I have just the absolute value of x, well, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, so this would be 2, 2. I should change that setting really quick. The absolute value of 2 is 2, the absolute value of 3 is 3, the absolute value of 1 is 1. But because I can't have a negative when I take a number's absolute value, what happens on the other side of the graph is that you end up with the absolute value of -1 is +1. Or the absolute value of -3 is +3. And you end up with these points that don't go below the y-axis on the original absolute value function. So you end up with what kind of looks like a V shape. Okay, now our function, when it gets a little bit more complicated, I can move it around the graph and I end up with a times the absolute value of x minus h plus k. So what I would encourage you to do is, if you're watching this for the first time, or if you don't remember what a, h, and k do, is I would go to desmos.com. And what I would do is I would type in y equals, and down at the bottom, there's an ABC button. You can get a, and then I will use the absolute value bar that is right above the ABC. And then I would type in x minus, go back to your keyboard of h, and then plus k. Make sure that plus k is outside of the absolute value bars. One way that you can do that is you can hit the right arrow underneath the functions button, or you can hit the right arrow on your keyboard, and you'd get y equals a times the absolute value of x minus h plus k. And you can play around with these sliders and just identify what is it that the a does when you slide it around. So what does a do? What does h do, and what does k do? And I would try that. I would play with that for, I don't know, 3, 4, 5 minutes until you identify what each letter does, and then go back to your notes here. So what does a do? A can stretch or shrink. If a is bigger than 1, if the number out in front of your absolute value is bigger than 1, so for example, if you had 2, if you had y equals 2 times the absolute value of x, that would make it stretch, it would make it taller. And if a is less than 1, or if it's a fraction, right, so somewhere between 0 and 1, that would make your graph shrink. It would make it shorter. And what I mean by that is, as a gets larger, so here's 1, as I get a larger a value, as a gets bigger, my graph is being pulled upward. And as a gets smaller, the graph is being squished down. It's being pushed down. So the sides are being pushed down, and it's being shrunk. So that's the stretch or shrink. That's what a does. A can also do something else. If I were to make a negative, it can flip my graph over the x-axis. It can flip it down. It can flip the graph up and down depending on if a is positive or if a is negative. h, if you play with that slider, you'll see that h would shift the function or the graph of the function left and right. But what's important is you have to think opposite signs. And the reason for that is if it's x minus h, if I had x minus and h is really negative 3, well, h is negative 3. But what you're going to see is that double negative is going to be turned into a positive. So if you ever see a positive inside those absolute value bars, really what's being subtracted is a negative. Your h is really negative. So if you ever see a positive, really it's a negative 3. And if you're subtracting a positive 3, then it's just subtraction. So the signs are opposite. And for k, for your k value, k would shift the function up and down. And that one you don't need to think opposite signs for. So h moves your function left and right. A can make it stretch upward or shrink downward. It can also flip it upside down. And k would move the entire graph up and down. It moves that point, the vertex point, up and down. Okay, so a quick recap. Our absolute value function is y equals a times the absolute value of x minus h plus k. If I want to find the vertex, it's really just those numbers, h and k. But remember, you have to think opposite signs for h, and the slope can be found from the a value of the graph. So let's look at some examples. My a value, it's less than 1, so that is going to shrink the graph. It's going to make it half as tall. Now a quick note here is that your slope is that a value. Your slope is going to be 1/2. It's a positive 1/2, so the graph does not flip upside down. Your left and right movement is that h value. That's the number inside the parentheses with the x. And usually I would think opposites, but the opposite of 0 is just 0. There's no positive or negative 0. And then my k value tells me how far up and down I go. And if it's -1, that would mean I would go down 1. So my vertex is at 0, -1, which means I go down 1. And I need to make a slope of 1/2. So I'll go rise 1, run 2, rise 1, run 2. And then on the other side, if you remember what that graph should look like, it should look like a V. So I'm going to go up 1 and left 2, and I'll have a slope of -1/2 in the other direction. So I have a slope of +1/2, I have a slope of -1/2, but each one uses that fraction of 1/2. Okay, let's just focus on that for right now. Let's just ignore the domain and range for right now. Let's look at the vertex and the transformations. So first thing I notice, I have a -1 outside my absolute value bars. So the transformations, I know if it's negative, it should flip down. So I'm going to have an upside down V for this graph. I see +1, so I need to really think opposites inside those parentheses or inside those absolute value bars. So that's really a negative 1. That's my h value, because if you remember x minus negative 1, well, I'm going to show that to you as a x plus 1. So when you see x plus 1, really it's not plus 1, it's minus negative 1. So I have negative 1 comma, and then my k value is 0. So that means if h is negative 1, I went left 1, and 0, I go up 0. So left 1, up 0. And then to find the slope, I look at that a value of negative 1. My slope, I'll go negative 1. I know it should open downward. And then when I get back to that vertex, I'll start back at that vertex. And I'm going to go down and to the left as well. So that way I get my V shape. So my slope is negative 1 or positive 1 on the left side. I'm making a nice V shape there with my 1/1 slopes. And again, we'll talk about domain and range in a few minutes. Let's try these next two. What I would encourage you to do is maybe find some graph paper or sketch out your own graph paper and find the vertex, the slope, and the transformations of these graphs. Okay, now number 3, I've got an a value of negative 2. Well, if a is negative, I know that flips it down. If it's 2, that's bigger than 1, so it's going to stretch by 2. It's going to be twice as tall. Okay, that's just the a value. Now the h value, I see plus 1, but I think negative 1. So left and right, that's going to be left 1. And then my k value is a negative 3. So up and down, if it's negative 3, that would be down 3. And my slope, I know, is a negative 2, or negative 2 over 1. So I'll find that vertex, negative 1, negative 3. And I'll do my negative 2 slope. So I'll go down 2 into the right, down 2, left 1. And I'll make my nice V shape. So there's my V. Why don't you try number 4 on your own? I would pause the video and try that, and then unpause and check your work. Okay. Now that you've tried this one on your own, you should know that your slope is 1/3. If it's less than 1, that fraction means that it's going to shrink the graph by 1/3. It's going to be 1/3 of its original height. This plus 2 is really minus negative 2, so that's a negative 2. But the number outside, you never change that one sign, so that is still a positive 2. Negative 2 for my x means I go left 2. Positive 2 for the y means that I go up 2. So I'll go left 2 and up 2. There's my vertex at negative 2, comma 2. And I'll make my slope of 1/3. So I'll rise 1, run 3. Rise 1, run 3. And I'll do the same thing on the other side. I'll rise 1 and go left 3 to make my nice V shape. And there's my absolute value function. It got squished downward, or shrunk downward. All right, I do have 2 more. Maybe we should try these before moving on to domain range. I would write this one as 2 times the absolute value of x, and there's nothing else in there, so I could write that as plus 0 minus 3. I would find your slope and your vertex and your transformations. Really, that's transformation. I don't know why I put comparison there. and then I would unpause and check your work. So your vertex here should be 0, -3. That 2 out front means that you're stretching that function. It's getting taller because it's bigger than 1. It's getting taller by 2. Your slope then we know is 2/1. You didn't go any left or right because that's a 0, but you did go -3 up and down, which means you went down 3. And if I find that point of 0, -3, there it is, left and right 0, down 3. And then I will do my slope of up 2/1 and up 2/1 all the way on both sides until I get that nice V shape, that nice absolute value shape. Okay, on the other side on number 6, my slope is about 1/4. Well, it's exactly 1/4. That -2 we know is really a +2. Well, in the x direction, +2, I know that is right 2. I should really do the a value first. 1/4 is less than 1, so I will shrink that by 1. By 1/4, and then up and down. If it's +3, that should be up 3. You can graph that one on your own, and then let me know how that goes. Check out the other videos. I'll see you.